Hi, hello everyone. Welcome back to De La Cruz Engineering Videos. Once again, this is Engineer De La Cruz, and in this video, we'll be continuing to discuss and solve problems related with fluid flow and pipes. So specifically, the sets of problem I prepared here are all about the pipes connected in series and also pipes connected in parallel. All right. So let's start to solve this first problem here. The concrete pipes are connected in series. As we can see in the figure here, no? If the rate of flow in the pipe is 0.1 cubic meters per second, we are required to determine the total head loss in meters. So may choices pa dito, no? It is like a board exam type of question. So the datas of each pipe are tabulated dito. We have the lengths, L corresponds the length, D corresponds the diameter, and F corresponds the friction factor, no? So yung subscript nila will denote that is for pipe 1, pipe 2, and pipe 3. All right. So if you are required to calculate the total head loss in meters, of course, dapat we'll be using a head loss formula. All right. So as we remember, as I have discussed last video, part 1 of this series, I presented to you the formula for Darcy-Weisbach, formula for Manning's formula, and also for Hazen-Williams. So dito, we can say that we should use the Darcy-Weisbach formula since yung binigay na factor is friction. All right? I hope you remember that formulas, no? So to calculate the total head loss, we should use the Darcy-Weisbach formula, which is derived ito. This is for metric system, no? 0.0826 FLQ squared over D raised to 5. Again, this is for metric system lang. For yung general formula dito is FL over D multiplied by V squared over 2G. Yan yung general formula for the head loss, major head loss for Darcy-Weisbach. All right. So we'll be using this. Now, we should know two principles dito to deal pipes in series. All right. For pipes in series, the total head loss, the total major head loss is equivalent to the head loss or the sum of all head losses on each pipes. No? Bakit ba ganito? So mamaya ipapakita natin. That is, makikita natin yan sa energy grade lines. Alright? And also, the discharge at any pipe must be equals to the discharge at all pipes. Bakit equal sila lahat? Because kung ano yung papasok na water dito, of course, yan yung lalabas dyan at a specific period of time. Diba? This is the continuity equation. Alright? So, basically, ganyan. Kung ano yung papasok dito, yan yung papasok dyan at yan lang din yung papasok dito sa pipe 3. Okay? I hope this is clear. So, madali lang siyang intindihin. These principles. Alright? So, since we have the datas here, we have the friction, we have the length, we have the discharge. Of course, discharge must be constant. We have the diameter of corresponding pipes. Then, we can directly solve this using that formula. Alright? So, diretso natin. 0.0826, yung discharge natin is 0.1, no? Now, as we can see, 0.0826 and yung discharge natin are constant, then i-factor out na lang natin. Right? Just factored out the discharge here and the 0.0826 na coefficient. Okay. So, what will remain in this parenthesis will be the frictional factor 0.02 for pipe 1, length is 350, diameter must be in meters. So, 210 converted to meters, that is 0.21 meters raised to 5th, of course. Alright? Plus for pipe 2, Okay, you can just follow the parameters dito. And for pipe 3, follow these parameters here. Yung friction is 0.025. Yung length is 500. Of course, yung diameter is 0.25. Raised to 5 yan. Okay? So, directly we can solve the answer. Total head loss. And actually, pipes in series connection is more easy than the pipes in parallel connection, no? And may mas mahirap pa yung combination of parallel and series connection. But sa board exam, no? If you look the CE reference from the board from let's say from CE board 2010, no? From 2010 to 2019, no? Walang lumalabas sa combination kasi mahirap kasi 'yon. Matagal siyang isolve, no? So, of course, if you are preparing for the board exam at hindi naman masyadong nag-i-aim para mag-top, study this one, no? Wag na yung mga masyadong mahirap na topics, na. Yung mga board exam related problems talaga. Alright? Alright. So, bakit ba ganito? Let's try to draw the energy grade line. Okay, suppose this is the energy at A. This is composed of potential energy and kinetic energy, no? Dito in terms of head tayo, no? So, we'll be assuming that the pipe is in horizontal position. Ito yung energy at B natin. Now, if we'll do the energy grade line, it will become like this. Yan. Okay? May head loss tayo on each position of the pipe. From here to here, may head na nawala. So, that would be energy minus head. That is HL1. Dito rin, may HL2 tayo. Dito rin may HL3 tayo na wala. Therefore, as you can see, this total head loss here must be equals to HL1 plus HL2 plus HL3. Yan. No? Mas madali siyang i-observe pag may figure tayo na makikita. No? For me, no, that is my one technique in studying. I will familiarize the figure, not the formula. Of course, needed natin i-memorize yung formula. But if kaya nating i-imagine yung figure kung saan yan nanggaling, mas madali siyang i-observe. No? That is for me, no? That is for my opinion because yan yung ginagawa ko. I don't usually memorize formulas talaga. I do the figure first in studying, no? In studying, I'll do the figure first and familiarize the figure bakit ganito yung nangyari sa ating equation. Yan. Alright? Well, anyway, it's up to you pa rin. Ano yung comfort way nyo para mag-study. Alright? So, this is for pipes in series. Let's have pipes in parallels naman. Okay. The total flow in the pipe system in the figure is 0.86 cubic meters per second. So, pag cubic meters per second, that is the discharge or Q, no? So, the constant frictional factor is 0.032 for all pipes. So, lahat ng pipes are of the same frictional factor, F, no? And we have the data here for each pipe run. Now, yung question dito is the flow on each pipe 1 or line 1, line 2, and line 3. So, how can we solve this one? So, kanina, may principle tayo about for pipes in series. Dito naman sa pipes in parallels, medyo nagbago yung principle natin dito. Okay, by the way, if yung discharge natin is 0.86, that is the total flow, this one, now imagine nyo, ano yung mangyayari sa flow at this portion dito? Ano yung mangyayari sa ating flow? That should be distributed to that pipe. Is it correct? No? Of course. Alangan namang if open lahat ng pipe dito, pag nilagyan natin ng flow dyan, dito lang dadaan yung tubig. Of course, dadaan din yan dito sa line 1 and of course in line 3. Basta open lang yan. No? So, in this figure, we can say that the total discharge must be equal to the sum of the discharge on each line 1, 2, and 3. No? Yan. So, in this case, we can say for parallel pipes, the discharge at line 1, line 2, and line 3 should be equals to the total discharge, which is 0.86. Ayan. And dito rin, mag-change yung principle natin about the head loss. That would be the head loss at 1 is equivalent to head loss at 2 or an equivalent to head loss at 3. So as you can see, yung head loss natin basta parallel pipe are constant. Nagbago na siya. Now, paano nyo siya ma-imagine dito sa figure? Bakit constant yung ating head loss dito for each pipe? Now, look at this one. Lagyan natin ng drawing nga natin para mas klaro. If we'll try to focus on these points, 2 points on this junction, this one and this one, let's say A and B yan, if i-draw natin yung energy grade line here, suppose dito galing yung ating flow, no? So let's say this is the total energy at A, yan. And ito yung energy natin at this junction B, ayan. So if this is the energy, erase lang natin. Now, connecting these two, ayan, if that is our energy grade line, then if this is the energy, total energy at A, and ito yung total energy at B, then ito yung nawalang head natin or nawalang energy. Yan. Or basically, yan yung head loss. From the word head loss, yung nawalang head energy. Yan. Yan yung head loss natin. Alright? Now, as we can see, in this inclusion dito between these points A and B, nandyan yung tatlong pipes natin. So, yung energy natin, yung head loss natin, as we can see, for pipe 1, 2, and 3 is isa lang. The same lang sila. That's why we can say that the head loss on pipe 1, pipe 2, and pipe 3 are all equal. I hope naintindihan nyo. Right? Sige, so let's continue. Now, how can we solve the value of discharge on each pipe? Now, remember that we can use this formula, the discharge formula, the head loss formula in Darcy-Weisbach. Again, this is for metric system lang, no? This is for the metric system. Now, as we can see, the head loss here are constant. Constant yung head loss natin, but the discharge are not constant between these three corresponding lines. So, ang gagawin ko dito is we'll be expressing the discharge to the head loss. Since, again, constant nga yung head loss natin. Bali, yung una nating kukunin is yung head loss. So, konting algebra lang, no? Cross multiply, then square root para maging Q in terms of the head loss. Ayan. Okay? Now, we'll be substituting this Q dito. For Q1, substitute natin dyan. Of course, yung diameter, yung friction, and yung length natin for corresponding pipes, yung magbabago. For Q2, for Q3. So, what will I do here is, gagawin ko siyang ganito. KL. Because if i-diretso natin to sa calculator natin, medyo mahaba siya. Medyo mahaba siya sa calculator. Pwede tayong magkamali. No? So, what will I do is, we'll be calculating or separate natin yung constant K natin dyan. No? And ititira natin dito is the HL o yung head loss. So, ang mangyayari, pag ganito, kunin muna natin yung corresponding K. Ayan. So, bali yung K is D raised to 5 over 0.0826 FL. Okay? So, yung matitira dito is square root of HL na lang. So, kunin ko yung K1. So, K1 is diameter of pipe 1. We have here 400 mm or equivalent to 0.4 meters. Follow this one. Constant friction natin lahat, 0.032. The length for pipe 1 is 400 meters. Okay? So, that will be 0.0984. So, I suggest save natin siya. No, save natin siya kay A. For K2, so just follow the parameters dito. I hope you can just do that. Okay? And that is, save ko siya kay B. For K3, just follow the parameters for pipe 3. Of course, yung friction natin are constant. Then just store this one. Store natin siya kay C. Ayan. Alright. So, papakita natin to use the calculator dito. Okay. Gamitin natin yung calculator. Okay. For pipe 1, that would be mas madali siguro if i-variable ko siya para mas edit na lang tayo. 26F. Ang F natin is constant naman. We have here 0.032. Then, yung L natin, let's say ang L is naka E. Pwedeng ganito. Okay, para calc lang ako. Yung diameter for K1, yung diameter for pipe 1, we have here 0.4. Yung length for pipe 1E is 400. Alright, so this is the value. Okay, store ko siya kay A. Okay. Now, how about for pipe K2? Calc. So, diameter for ating pipe 2 is 0.6. Yung length is 350. So, equals, store ko siya kay B. Okay? So, recall ko lang. Calc. Diameter for pipe 3 is 0.5. Length for pipe 3 is 420. Equals, and this is for our K3. Okay? I hope kuha nyo. Now, tanggalin ko muna yung calculator natin. Okay? So, move ko. So, following this equation here, no, and Q being K squared of HL, so magiging ganito yung equation natin. This is Q1. Okay? This whole term is Q1. This whole term is Q2. This whole term is Q3. Now, as we can see, we already have K1, K2, and K3 here. No? And yung unknown natin is the HL. Is it correct? No? So, we can directly solve HL. Just do shift solve. No, we have the calculator naman. HL here is 2.392. Now, as you can see, napaka tipid na sa calculator natin dito because nakastore na yung K1, K2, and K3 natin. Okay? Sige, gawin natin sa calculator. Alright, so sa calculator natin, nakastore man yung ating values. So, let's say, A, this is for K1 square root of HL. Actually, we can factor out square root of HL, no? Factor out na lang natin. Square root of HL, of course, yan yung unknown natin, no? A plus B plus C. Ayan. Then, alpha equals 0.86. Ayan. So, shift solve. A natin nakastore dyan. B nakastore dyan. And C nakastore dyan. So, approximately yung H natin is 2.392 meters. Okay? So, yung HL natin dito, naka-store na siya automatically kay XX. Ayan. No? Therefore, the corresponding discharge for discharge 1, that will be AX. No, square root of X. Yan. Ito, yung discharge natin sa line 1 is K1 square root of HL. So, this is K1 square root of HL. That is 0.152 cubic meters per second. For B naman, i-change lang natin yan for pipe B. We have here 0.448. Okay? So, napakadali. For C, or for line 3, we have here 0.259. I hope kuha nyo. No, napakadali pag ganito yung gagawin natin. Alright? So, magiging ganito yung equation natin for discharge 1. And ito yung discharge 2, 0.448. And ito yung discharge 3. That's it. Okay? I hope kuha nyo. Tingnan lang natin if may example pa tayo sa ating parallel. Yung next problem natin is all about reserva problem. So I will record this or answer these problems on the next videos. No? So medyo mahaba na yung video natin. So I hope you enjoy learning. And if you like this video, give this a thumbs up. And also you can subscribe to our channel para mag-grow naman yung channel natin. Okay? So thank you and bye-bye.